tersebut, Fakultas Perikanan dan Kelautan menggunakan
ini udah ada Bang Ghazali nih.
kurikulum yang baru, yaitu adalah kurikulum Merdeka Belajar Kampus Merdeka, yang Fakultas Perikanan dan Kelautan telah terapkan dengan lebih kurang 10-15 SKS untuk masing-masing program studi. Di samping itu, untuk mendukung profil lulusan mahasiswa Fakultas Perikanan Kelautan sesuai dengan kompetensi di bidang ilmunya, Fakultas Perikanan telah memiliki tempat uji kompetensi untuk menguji kompetensi keilmuan daripada mahasiswa tersebut, sehingga diharapkan mahasiswa yang lulus betul-betul dapat memasuki dunia kerja sesuai dengan kompetensi di bidang keilmuannya.
Untuk mendukung pembelajaran dan pelayanan kependidikan pada Fakultas Perikanan dan Kelautan Universitas Riau terdapat pendidikan yang terdiri dari tenaga administrasi, pustakawan, peranata laboratorium, dan teknisi. Kami terus berupaya meningkatkan pembelajaran dengan melengkapi fasilitas pembelajaran seperti ruang kuliah yang nyaman, laboratorium yang lengkap, sarana dan prasarana.
Kok jalan dia?
Sampai juga meningkatkan pelayanan pendidikan dengan membenahi sarana dan prasarana perkantoran, meningkatkan sarana pengembangan potensi seperti tempat berolahraga, tempat berdiskusi, dan tempat-tempat untuk bereksplorasi di lingkungan kampus.
Mahasiswa di Fakultas Perikanan merupakan suatu aset terbesar yang kita miliki. Selain menimba ilmu di kelas, tentunya mereka perlu peningkatan kapasitas melalui kelembagaan dan keorganisasian yang ada, antara lain BEM, kemudian juga ada BLM, dan juga ada UKM. Tiga UKM yang ada di Fakultas Perikanan. Tentu wadah ini merupakan salah satu wadah untuk mengasah kemampuan mereka dalam berorganisasi. Dalam pengembangan Fakultas Perikanan sudah dilakukan beberapa sinergitas kerjasama dengan pihak luar, antara lain kerjasama dengan pemerintah daerah, pemerintah pusat, dan beberapa perusahaan swasta yang ada di Provinsi Riau. Dan juga kerjasama yang kita lakukan juga dengan pihak luar, lembaga riset yang berhubungan dengan Fakultas Perikanan dan Kelautan. Tentunya semua kerjasama ini merupakan suatu hal yang sangat baik untuk meningkatkan kemampuan lulusan kita nantinya dan mahasiswa untuk bisa magang, dapat pekerjaan yang lebih baik di masa yang akan datang. Mahasiswa Fakultas Perikanan dan Kelautan Universitas Riau telah mengukir berbagai prestasi di bidang akademik dan non-akademik, baik tingkat nasional maupun tingkat internasional. Pada tingkat nasional, sebagai juara 1 penulisan esai di Provinsi Riau, sedangkan pada tingkat internasional sebagai the best idea pada acara Asia Youth Cultural Expo Thailand tahun 2019, dan juga di bidang olahraga atlet angkat ASEAN yang sudah mengikuti berbagai pertandingan di Malaysia, Singapura, dan Thailand. Sampai tahun 2020, alumni kita tersebar di seluruh Indonesia, kemudian di berbagai mancanegara. Alumni yang tersebar ini merupakan suatu kekuatan yang selalu bermitra dan memberikan suatu dukungan kepada Fakultas Perikanan untuk dalam tujuan memberikan informasi dan memberikan segala bantuan baik itu fisik maupun material maupun moral untuk pengembangan pengembangan Fakultas Perikanan dan Kelautan yang kita cintai.
Kami tenaga pendidik dan kependidikan bersama-sama bertekad dan menumbuhkannya untuk bahu dalam mewujudkan visi dan misi fakultas sehingga mampu berkontribusi secara maksimal di dalam proses pendidikan dan pencerdasan seluruh anak bangsa dalam bidang perikanan dan kelautan. Sekali layar terkembang, pantang turut ke belakang.
Masker Pak Joko. Yang ada pakai apa?
Halo. Halo, panitia. Selamat siang, panitia.
Apa ya?
Selamat siang Pak Joko.
Boleh dimulai?
Belum.
Pak kan sudah.
Kenapa? Yang mana siapa? Dari kamar, jadi takut.
Ini ada masalah juga kak?
Kalau saya juga berarti kerja pengusaha.
Oh bukan, itu juga kan? Halo, Assalamualaikum, panitia. Boleh saya mulai, panitia? Halo, panitia. Halo, panitia. Boleh saya mulai?
Silakan Pak, dimulai.
Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good afternoon for everyone. Dear speakers, the honored Dr. Rambujel, Dr. Satoshi Nagoi, Dr. Nurul Huda, Professor Dr. Ahmed Al-Haribi, and also Dr. Sofyan Hussein Siregar. It is our pleasure that all of you able to respond positively about our request. So on behalf of the faculty and also the university, I would like to thank you all, and also to all participants who are coming from Riau and also other places in Indonesia. We would like to greet you and welcome to Pekanbaru, although it is through the online system. This is our 9th international seminar on fisheries and marine science that is conducted by our faculty. So since 2011, we have done this every year, and we would like really thank for all friends, colleagues who ready to be the speakers. And here we would like to share the result of our studies and also findings, and hopefully it can be used for the future development of our science in marine science and fisheries. Once again, warm welcome to all of you, the participants, the speakers, and our students from all over Indonesia. Now I can see that from the monitor, there are 108 participants so far. I don't know for the YouTube viewers, maybe the committee will tell us later. Yeah. Once again, thank you very much. And now for the second agenda is please welcome Ibu Dr. Morina Riawati, who will lead for the Indonesian National Anthem. Please, Ibu Morina. Many thanks indeed for Ibu Morina, who has led us to sing the Indonesian national anthem. The next program is prayer that will be led by Dr. Zulkarnain Umar. We hope that our program will get through smoothly during today and also tomorrow. So I would like cordially to invite Dr. Zulkarnain to lead the prayer. Would you please unmute your speaker, please? Pak Ustadz, Pak Jul, please unmute your speaker. Belum di-unmute, Pak Ci.
Sudah.
Speaker Bapak belum. Oke.
Tadi belum diizinkan sama ininya.
Hostnya. Oke.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Participant in international and national seminar, Fisheries and Marine Science. Let's we start pray together. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin sayyidina wa nabiyina Muhammadin wa ala alihi wa sahbihi ajma'in. Allahumma ja'al jam'ana hadza jam'atan marhumah wa tafarruqana min ba'dihi tafarruqan ma'sumah. Allahumma anzilir rahmah wal hidayah wasyakinah wal mawaddah wal maghfirah wal barakah khususan ala hadhihi jamaah seminar internasional nasional Fisheries and Marine Science ya rabbal alamin. Ya Allah ya Rahman ya Rahim ya Karim. Allahumma barik lana fiha warzuqna janaha wa habib ahliha wa habib salih ahliha ilaina bi rahmatika ya rahimin. Ya Allah ya Tuhan kami, ampunkanlah dosa-dosa dan kesalahan kami ya Allah. Jadikanlah pertemuan kami, seminar kami Fisheries and Marine Science ini ya Allah. Datangkan rahmat dan kasih sayang ya Allah. Jadikan kesudahan dari majelis kami ini kesudahan yang menghapuskan dosa-dosa dan kesalahan kami ya Allah. Ya Allah berkahilah kami semua yang ada di sini ya Allah. Allahumma barik lana fiha warzuqna janaha, dan berikanlah kami rezeki dari setiap apa yang kami lakukan ya Allah. Wa habib ahliha, dan berikanlah kami kasih sayang, anugerahkan kasih sayang di antara kami semua ya Allah.
Amin.
Wa habib ahliha ya rabbal alamin, dan kasih sayang orang-orang soleh, orang-orang baik di antara kami ya Allah. Allahumma inna na'udzubika minal barasi wal junun wal juzami wa min syai'in asqam wa min fitnah virus corona khassah bi rahmatika ya rahimin. Ya Allah, kami berlindung padamu dari segala kesusah payahan ya Allah. Kami melaksanakan seminar di antara waktu-waktu di saat pandemi Covid ini ya Allah. Jauhkan kami ya Allah dari segala wabah ini ya Allah. Kami bermohon ya Allah kepadamu, lindungilah kami yang ada di seluruh dunia ini ya Allah dari wabah fitnah virus corona ini ya Rabbal alamin. Kabulkan doa-doa kami ya Allah. Sukseskan acara kami ya Allah dalam berkah dan rahmat-Mu bi rahmatika ya arhamar rahimin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Subhana rabbika rabbil izzati amma yasifun. Wassalamun alal mursalin walhamdulillahi rabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Amin amin ya rabbal alamin. We hope Allah will give us His blessing, so our seminar will run very smoothly. Thank you very much to Dr. Zulkarnain Umar. The next program is the opening remark, and officially open the seminar. I would like to invite cordially Professor Dr. Bintal Amin, the Dean of our faculty. Would you please, Pak Bintal Amin?
First of all, on behalf of the Faculty of Fisheries and Marine Science, we thank you of Riau for the respected great program and all of the students Organizing military operations by the five. Then you have the Mahmud as a participating of your organization. And also there is Dr. Salam from the Federal of Riau. We would also like to congratulate for joining us today and tomorrow to share with knowledge and perspective on fisheries science in and international and national seminars on fisheries and marine science of the science we are 2020. Usually, we conduct this kind of seminar offline. Well, people are coming to our past in the city of Pekanbaru. Due to COVID-19, we decided to house the event through our system. Saya sendiri dari sebenarnya dan free time and has been conducted every year and we last I think before by the organization committee. This year we have about one paper to set the market on education. We are able to have and also from Europe, Japan, Thailand, Malaysia, etc. We do realize that there is a important sources of food, nutrition, income, and livelihood for hundreds of millions of people around the world. Fish also contributes to one of the most commodities worldwide. Report by expert, international organizations, industry, and civil society representatives, all highlighted the tremendous potential of the ocean and even water. And even more so, to contribute significantly to food security and adequate nutrition for global population. Effective to reach 9.7 billion by 2050. Marine animal fishery sector has been recognized as a powerful income and employment generator as a full of security infrastructure. At the same time, it is an important livelihood for income generator of more than 1 billion world fishermen and fishermen mainly in the developing countries, including Indonesia. Two-thirds of the fish supply was from captive fishery. 1/3 derived from aquaculture. In the last decade, however, the captive fisheries of production remains sector only 3% of fish production. The highest aquaculture fish production was reached by production, while Indonesia is second position, with the production around 16.5 million tons. The demand for this space continues to increase with the increase of the world population of the world and increases to health and worldwide. More than 1 billion people rely on fish as their main of the main growth. And the world population has at least 1% of the revenue from fish from as the demand of fisheries and milk products is in the increase, industrialization and diversification of aquaculture practices, therefore would be the recommended way to meet that large-scale demand. Ladies and gentlemen, Indonesia has a national goal on marine and fisheries as dominant to conserve and develop sustainable fisheries resources, to contribute and to ensure people's food security and socio-economic development in order to enhance people's livelihood, education, prosperity. University of Riau, the Faculty of Fisheries and Maritime, has a moral responsibility to support the government program. Learning outcomes and technology produced by the university should be relevant to skills and technology needed by fishery industry. Finally, I would like to extend our sincere to organize a community that has been endeavored to succeed with wildlife. I hope that this webinar will give benefit to all of us, and we will see each other again with a similar event in the years to come. By saying Bismillahirrahmanirrahim, I officially open 99 national seminars on fisheries and maritime 2020. May Allah bless and great success. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Pak Dekan. Would you please knock the gong in front of you, Pak Dekan? Pak Bintal, would you please knock the gong in front of you? Yeah, and also Ibu Windarti may come on the stage as well. Pak Fauzi, Pak Sofyan. Okay. Bu Windarti, Pak Fauzi, Pak Sofyan, Pak Rahman Karnila, and also Pak Mulyadi.
Wow.
Okay. Yeah, please. Please, Pak Bintang. Okay, thank you very much. Now all of you may come back to the stage. Now all of you may be seated, please. Ladies and gentlemen, our honorable guests and also colleagues, students, now comes into the presentation. Before I invite the presenter, I would like to thank for the committee that led by Ibu Dr. Windarti, who have done a very long and also hard preparation during this pandemic situation. However, the committee overcome the problems and finally able to conduct this seminar. And I would like to inform to all of participants that the seminars is conducted in Grand Elite Hotel in Pekanbaru, but for the moderation, I moderate this seminar from a very small city. It is called Pandan in Tapanuli Tengah Regency, North Sumatra Province. So by using this modern technology, we able to connect each other. Alhamdulillah, and hopefully the connection is always in a good condition throughout our seminar program. So now I would like to invite the first keynote speaker from Japan, and his name is Dr. Satoshi Nagai. He's coming from Japan Fisheries Research and Education Agency in Yokohama, Japan. Dr. Nagai hold a BSc in Fisheries Science from National Fisheries University. He got it in 1989, and then his PhD in Biological Oceanography was sorted in Kyoto University in 1996. Dr. Nagai has an expansive publications, and his area of works are concentrating on diatoms and also the harmful algae. So when you see about skeletonema, dinoflagellates, dinophysis, diatoms, alga bloom, toxin, compound markers, then Dr. Nagoi is the right person to ask. He holds a number of 10 awards, of course, at national and international level, and he has 4 patents. Of course, once again, the area coming from algal harmful bloom, how to detect this, and then surface poisoning, detection of gene mutation in Manila clams, and the last one is the novel virus and cryptophysae. And he has been invited as main speakers in 16 different countries in the world. So I count from his CV that he has been invited into 16 different countries, from Russia up to Chile and South America. So today we would like to have the lessons from him with the title of Detection of each AB species by DNA technology. So would you please, Dr. Satoshi Nagoi, and please welcome him to give his topics. Time is yours.
Can you see me my slide?
Yes, it is very clear.
Thank you very much. Yeah, thank you very much, Professor, your kind introduction about me. I'm highly grateful to the committee members, including Sophia, for giving me this great opportunity to give a talk about my research activity to mainly maybe Indonesian researchers. So I'm very happy now. So today my topic is a detection of HAB species by environmental DNA technology, mainly in Japan. So this is Japan. Okay. So the Seto Inland Sea is one of the largest semi-enclosed sea, which is located in the western part of Japan. These areas are one of the most industrially developed area in Japan. In the 1960s, the coastal region played a leading role in contributing to the explosive economic growth of Japan, resulting in the production of large amount of pollutant, and consequently giving rise to serious eutrophication. But at the same time, the aquaculture of fish, such as yellowtail and red sea bream, have become popular in the eutrophicated Seto Inland Sea. So fresh and raw fish were have been provided from here to big city like Osaka or Tokyo. So as you know, Japanese people love to eat sashimi. Mm-hmm. But unfortunately, in the summer of 1972, Chatonella microalgae formed an extensive bloom. And so killed 14 million cultured fish, worth nearly 75 million US dollars, especially in the eastern Seto Inland Sea. So this was a catastrophic event. This killed a lot of yellowtail like that. So a very serious public concern. After that, government made a law to regulate water waste coming from a factory. So control the COD and nutrients such as total nitrogen and phosphorus. So this figure shows the interannual changes in blooms of HAB and the damage amount. So I showed the data in Seto Inland Sea and also Kyushu area. Kyushu is located in the southern part of Japan. From 1970, the number of blooms almost reached over 300 cases per year. But after that, gradually decreased. So recent 30 years, we have had almost 100 blooms cases per year. So not increasing, but not decreasing. And bloom fish killing events, several cases are reported, not so increasing, not so decreasing. And a huge amount of damage by fish killing events were reported once several years before 2000, but after that, once 10 years reported. So I think a huge amount of the damage by fish killing events reduced in Seto Inland Sea. In Kyushu area, the number of bloom increasing gradually, but not decreasing. And every year, several cases, fish killing events were reported in this region. And a huge amount of damage also reported in the once 10 years. This is the present situation of HIV outbreaks and amount of damage in Japan. So I have conducted environmental DNA monitoring over nearly 10 years. So I have a lot of experience using this technique to cover from northernmost area of Japan, because we have a sea ice ecosystem, and southernmost area of Japan near Taiwan, we see with ecosystem, and we have a fish ground ecosystem. Aquaculture industry are very active. But unfortunately, a lot of HIV appear around here. So I have also conducted HIV monitoring using eDNA technology. So let me introduce a little bit background of the eDNA research. As you know, it is difficult to know which marine eukaryotic species had appeared in the past because cells are fragile and do not fossilize in most of the species. So preservation of appearance record would be very important. And it's difficult to identify species smaller than 10 micrometers in sizes. So morphology-based observation is hardly possible to exactly identify pico-sized marine eukaryote, and light microscopy or even scanning electron microscope or transmission electron microscope, especially HEB, Alexandrium, Procentrum, Azadinium, and a lot of dinoflagellate and diatom is very difficult to exactly identify by light microscope. So we need to introduce this kind of molecular technique. Introduce a genetic-based technique with morphology-based observation. So we can now apply metabarcoding, so environmental DNA analysis to analyze or identify species, HAB species. So this is a basic scheme of eukaryotic metabarcoding. Probably, but let me explain. We usually collect 1 to 3 liters of seawater. It depends on purpose and also area. And then we seawater, almost all plankton component on the filters, and then extract the DNA from the filter directly. In case of zooplankton, we utilize plankton net to take a samples and extract the DNA from the pellet. And then in case of plankton, the genome sizes are so huge, so we cannot analyze whole genome. So we have to focus on the target region. Then we can utilize a PCR amplification using universal primers, such as ribosomal RNA genes or mitochondrial genes. But luckily, we can distinguish a sample by adding index. So we can mix many samples together from 100 to 150 samples together. Then get the sequence by next generation sequencer. And get a huge number of sequences. And then after that, after the data treatment, we can identify the species and also compare biodiversity. This is a basic scheme of metabarcoding or environmental DNA analysis. So today I'd like to show the result of the time series monitoring in Monbetsu. Monbetsu is located in the northernmost area of Japan, Hokkaido. So I recognize here as an important monitoring base at the northernmost area in Japan because in winter, sea ice is coming like that. And a -2 degrees seawater stay here for a while. So I can detect species which appear the lowest seawater in Japan. So from the viewpoint of climate change, I think we can obtain a good data to analyze the influence of the global warming and the change of species diversity. So I recognize this here as a very base. So we take a seawater or zooplankton by net from here. Then this is the monitoring details. Sampling was carried out once a week since April 2012 from surface layer by bucket from here. And today I would like to show you the result of the sample obtained from April 2012 to March 2019. So 394 samples in total. Then we conducted the metabarcoding. As a universal primer, we use ES and 28S universal primer, the ribosomal RNA genes. Then as environmental data, water temperature, salinity, chlorophyll, nutrients were measured, analyzed. This is an environmental data. Surface water temperature, salinity, chlorophyll, nitrate, phosphate, and silicate. But clear seasonal patterns were detected except for salinity and silicate. For example, nutrients were higher in the winter season, but lower in summer season. This is a summary table of sequence data of 394 DNA samples. This is a low data. So we got nearly 100,000 sequences in both genes in average. And after data treatment means after removal of errors or something, we got nearly 25,000 sequences. And then we utilized these sequences for further analysis. I think the number of sequences are good enough. So this is the frequency of the detected OTUs. In ATS, 20% was from alveolata, mainly dinoflagellate and ciliate. 21% from diatom. 28% from Ospitoconta, mainly in zooplankton and fungi. So 80% were occupied by these three groups. But 28S data was a bit biased. Although alveolata and Stromopyrus, such as dinoflagellate diatom were detected, but a lot of them were from Ospitoconta. But 70% of this 66% were from fungi. So biased, a lot of biased. But in both genes, we detected nearly 5,000 OTUs, and then 700 were overlapped. So I think not very bad. So I use the 20th data for the further analysis. This is a slide showing the change of biodiversity. So left figure shows the water temperature and the species richness, 18S and 28S. The line shows water temperature fluctuated from -2 to 23. So in this region, very cold region compared to Indonesia, I think. And the species richness tended to be higher in high water temperature season, but lower in low water temperature season. So high, low, high, low, high, low, high, low. So this trend was similar in 18S. This figure shows a Simpson's index. This value, when several species co-appears at a similar density, this value tends to be higher, around 0.9, but only a few species or a single species appeared, like a broom or diatom or something. This value decrease, showed lower, like 0.4 or 0.3. So these sharp peak show the broom via microalgae, such as a diatom or dinoflagellate, or even copepod. So as you can see, 18S and 28 days data are very, very similar, detected a very sharp peak. So even 28S are biased, but still could detect this kind of a sharp peak. And also I'm very grateful to my technician. This data reflect the technician's pipetting technique. So she precisely pipetted, then made a DNA library. So anyway, we can detect this kind of peak by environmental DNA analysis. So now I will show the criterion for species identification. My motivation to study this environmental DNA is how many species we can identify from the seawater samples. This is my motivation to continue this study. So this is a criteria. When the top hit similarity in blast search was higher than 0.980 and a single top hit showed a single species name, then the OTU was regarded as a species. So I can say I could identify the species. I showed 6 examples here. First one, second one, fifth one, sixth one, I succeeded in the identifying a species. Top hit similarity is higher than 0.98 and showed a single species name, Heterocapsa rotundata carolinum, and Gyronium rubrum. But the third one, not a single top hit, multi top hit. Fourth one, the blast top hit similarity was lower than 0.98. So I cannot say. We don't know which species are detected. Anyway, so I analyzed how many species we could identify from both genes. 1,434 species were identified from 18S data, and 1,300 species, one species were identified from 28S. 450 overlapped. So in total, 2,000 species, 2,238 species were detected, identified in total. I think this is a world record, which could identify the species in such a high number from one location. So this is a summary of the species identification trial. Alberata dinoflagellate, dinophysi, 198 species were identified, and Ciliocreophora, ciliate, 170 species. Diatom, 236 species. Fungi, quite many, 650 species. Metazoa, 400. Zooplankton, 474 species. And other microalgae or protists or macro, in total, 2,200. So I'm trying to, challenge a Guinness Book record now. And then, so today's main topics. What about HAB in Mombets? How many species we could identify, detect? So 43 species were, toxic HAB species were detected from this, but only previously reported. So nearly 30 identified newly from this region. So I think this data shows a great advantage to utilize environmental DNA analysis, especially pico-sized HAB species such as Alexandrium or Azadinium or Procentrum or Pseudonychia. So this is a change of relative abundances in HAB. So Alexandrium or Azadinium. Azadinium is very, very difficult to identify the species by microscopy because very, very small. But environmental DNA, metabarcoding, we can detect like this, the how to say, sporadical appearance, or then some species show clear seasonal pattern, significant seasonal patterns. So this is a very interesting data. Oreococcus. This species prefer to appear in the low water temperature season. So minus or at least than 10 degrees Celsius appears. So I think this is a greater potential of the environmental DNA metabarcoding analysis. And then this figure shows a Pearson correlations between environmental parameters and OTU based on 18S. Here show the name of a HAB. And so I try to analyze the correlation of the each HAB appearance with environmental parameters. For example, chlorophyll, salinity, water temperature, nitrate, phosphate, silicate, nitrate. So 8 species showed significantly positive or negative correlation with water temperature. And with phosphate, 6 species showed a significantly positive or negative correlation. Yeah, were detected. So these species mainly appeared in summer. That's why showed with positive correlation, showed a positive correlation with water temperature, but negative correlation with nutrients. These species opposite appeared in the winter. So negative correlation with water temperature was detected, but positive correlation with nutrients. So 28S data also showed similar pattern. So this is a very important slide. Show the changes of accumulative number of the identified species. I would like to know, I wanted to know how long we have to continue the weekly monitoring in this region to detect almost all species appear in Monbet city. 1 year, 2 years, 3 years, not good enough. But 5 years or 6 years, maybe good enough. We could detect almost all species appear in this region. So this figure shows the importance of continuous monitoring to detect almost all species appear in one region. Then frequency of the OTUs identified as species in blast search. From 18S, we could identify 25% of the total OTUs detected, 27% from 28S. So what do you think? 25, 27 is high enough or not high enough? This is the present situation of this technology. So probably this is a last slide, maybe. This is a factors influence the species identification success. So I raised 4: sequence quality, sequence length, the variability of primers, and depth of the database. So if sequence quality is higher, then we can identify species more accurate, because still sequence contains errors, we have to utilize for analysis. And the sequence length, if sequence length is became longer, then information will be increased. Then we can identify a little more species. The variability of primers. So if we can use, we can find better primers, we can identify the species more precisely. But if database is not, established, managed, we cannot identify the species But at least the first three factors, the sequencing technology is rapidly developing like rocket science. So let's see 5 years, probably now 25, 27%, but maybe we can identify the 40% or 50% of eukaryotic species in future. So this is my conclusion. And also HAB, we can detect more precisely. Thank you very much for your attention.
Thank you very much, Dr. Satoshi Nagoi, for your nice presentation. And it looks like that you did it in a very long time with a continuous monitoring program. And I hope the participants able to learn from your work, because it is demanding one, and also it is time consuming. And this is very important because in Indonesia, we also have seen many cases from the algal bloom in forms of red tide, yellow tide, green tide, and so on. And it is very important lesson from you that maybe can be used for future research in Indonesia. Maybe 1 or 2 PhD programs can take this topic as their research project. Because when we see also in Indonesian cases, we have found it in Jakarta Bay, for example, or in Riau Islands, in Batam coast areas, notably. It is very often happens, and this is really disturbing for the marine ecosystem. Declining the aquaculture and also the food chain and so on. Yeah, I think your research is really useful for us, and that's why in this kind of seminar is needed to explore what kind of trend and also how to overcome of this situation, particularly with tackling the marine quality. Yeah. Once again, thank you very much for your nice topic and also concise presentation. Yes, we as the committee allocate 20 to 25 minutes for each presenter. So it is a good slot for you, and you have done it in a very great way. Thank you once again.
Thank you very much.
Okay, now the second presenter is actually Professor Dr. Ahmed Al-Harbi. He is a scientist from King Abdul Aziz City for Science and Technology in Saudi Arabia. However, the committee has tried to contact him since 1 or 2 hours ago. Unfortunately, the committee has not been successful to contact him. Maybe the connection, or maybe something happens to him, but we pray that he is in a healthy condition, of course, yeah. So because of this situation, I would like to invite cordially Dr. Ram Bujel. Are you with me?
Yes, thank you very much. Can you hear me?
Yeah, yes. And I would like to inform about his CV, and before give him time to present his other nice topic as well. Yeah. So Dr. Ram Bujel works in Aqua Center in the School of Environment Resources and Development at Asian Institute of Technology in Thailand. Yeah. So he got his BSc in Animal Science from IAAS in Nepal, yeah, in Kathmandu maybe, yeah. And then his MSc was gained in 1994 from AET, and also his PhD coming from the same institute. He got it in 1999, and he has done a postdoctoral program in 2002 at University of Stirling in Scotland. Yeah, and his interest are covering wide areas in fisheries and marine science, but mostly with the aquaculture, for example, aquaculture and fisheries management, small-scale rural aquaculture, commercial aquaculture of tilapia, carps, catfish, prawns, and trout. And he is having an interest also in the gender studies from the social economics of fish farmer, yeah, and also he works for food security and also socio-economics analysis. And like our presenter before from Kyoto, Dr. Ram Bujel has also been invited to many places in this world. Yeah, so dear audiences, participants, today we really grateful to have this two guest speakers who have extensive experiences. And he has been invited to Nepal, Myanmar, Thailand, Cambodia, all over Southeast Asian countries, include East Timor, and then Bangladesh, Zambia, Sahara, yeah, you know Sahara in Africa, yeah, and then UK, US, Pakistan, Ivory Coast, even Fiji. Oh my God, yeah. So you are traveling a lot, Dr. Rambuchel, yeah. So today, he will present his works with the title of Food and Nutrition Security in the Context of COVID-19, yeah, and the potential of tilapia aquaculture. So in Indonesia, people do eat tilapia a lot, yeah. We eat ikan nila every day, yeah. So Dr. Rambujel, 20 to 20 minutes is yours.
Okay, thank you very much for a nice introduction. I'm sharing my slide. Can you see?
Yes, we can see.
Okay, thank you, organizer, also for inviting me for this opportunity. What I have learned from my side, being based in Thailand, traveling around the world, including Indonesia. So my topic, as Dr. Joko mentioned, food security, especially nutrition side and aquaculture, especially tilapia, I'll be focusing on. So what I try to see here is what we have problems of food security or other SDG problems, what SDG is setting for to achieve by 2030. And in the meantime, we have COVID-19 came to give more problems to us and how we can solve. So how aquaculture, especially different species like tilapia can be helpful in this direction or in this like a battle now. And some of the success stories I'll be covering. So first, in my opinion, and I think UN also is saying, our root problem comes from our population. If you look at the population last 10,000 years, population was less than 1 billion. But when industrial revolution happened, after that, we have so many medicines and population increased because people did not die early. So only last 100 years, you see 2 billion, from 2 billion to now we have 7.6 billion, and then we are expecting 9 billion. So 5 billion people increase within last 100 years time. That's the biggest challenge. How we will feed the world. This is the real challenge. That's why problem comes here. And Indonesia is one of them, actually having fastest population. Here I can see 263, or I don't know exactly now, maybe more, with the one of the highest growth rate. So, and Asia actually has 60% population of the world, 60%. So we have a big role to play, big, in terms of food security. And if we look at the nutritional part, big countries like India, Pakistan, Bangladesh, Indonesia, our small children under 5, they are actually stunted, stunted their size and then their weight because children don't get enough nutrition. I mean, nutrients from different sources. They are very limited food items we can offer, like maybe milk and rice all the time, many times. Eating fish is maybe very difficult for children. That's why we have, children, they are stunted. They don't get enough food, like what we eat every day, different food, but children maybe same food. So how these children can be, fed with the protein and other nutrients is a big question, because sometimes very small children cannot eat fish or some other items, meat, only maybe milk and rice or something like very easy to eat. So how we can prepare more food? Like this is very recent picture from shared by one of my friends in Africa. So they are at the moment, because of the COVID, many children are not getting food, or their parents maybe lost job. So what this would do, some communities, some farms are offering this tilapia to the children. So this is the good example how children can be fed. And also maybe there are other opportunities if you change the food item to powder, very nice powder, easy to eat, and then mix with the rice. So small children who can eat external food, they can actually take some of these. So these could help a lot, and these things you can keep for long. So you don't need to store in the fridge. They are well dried and also packaged. This is the product from Thailand. So these type of items could help a lot in terms of solving the nutritional problem in children and also even adults and old people. Now comes to the COVID-19, we have even more problems coming here. Even we have a food in different place, but other places maybe not. So if you look at the IMF data, what they are saying is global economy will shrink by 3%, but this was a little bit early, but recently maybe this will be even higher, more shrinking. So especially advanced economies, Asia maybe a little bit less, but still you can see India is saying about 23% negative growth. Thailand is expecting maybe about 10-15% negative growth. What will happen? We don't know. There will be a big challenge coming ahead of us. So when you look at the food and nutrition security, 3 billion people cannot afford regularly balanced diet. So there is a big challenge already in the world. There was now additional 132 million people based on recent FAO data. They are saying 132 million people already getting suffer, additional people. And we don't know how long this COVID-19 will continue, maybe until next year or another year, until vaccine is invented, or we are not sure even vaccine will be there or not. For example, HIV/AIDS doesn't have a vaccine yet, right? So a virus is very difficult to find a vaccine and also treatment. And Asia has, again, more people. That's why more problems will be there in Asia. If you look at these stores during this COVID-19, everywhere, every country had a problem. Food stores were almost empty. Everybody wanted to make sure they have enough food at home. That's why they buy so many, and other people don't get enough. So imagine in some countries, okay, they produce a lot of food, but some countries, they all import, like Singapore, 90% food is imported from other countries. Similarly, 90% seafood from in USA, they import from Asia and other countries. Imagine what is happening there. So food security is a big issue now. Like in Thailand, Thailand is food surplus country, I guess Indonesia as well. And but when I visited some of the seafood markets, there are no people there because they are worried about going in the group. But this is a little bit earlier. Now it is improving here, but still the businesses are all affected. Transportation, so many things affected. And if you look at here, this Ecuador, was #1 in exporting shrimp to China. And because of this COVID situation, this has gone down like this. The export-based industries are having a problem. This is another example in Thailand. Sea bass. This farm used to produce ewes like a 32 ton per hectare. So, and then they give this fish to the airliners. All the airliners, they were getting fish from this company, but once airliners stop their flights, everything is gone. So they keep for long, and then fish died because the volume increased, and then they could not manage. So huge things going on at the moment. Some farmers are losing fish. Some fishermen, they cannot catch, or even they catch, they cannot sell, they cannot transport to the market, from market to again home. There are a lot of interruptions going on. That's why food security, how can people get the enough food to survive, or to get enough nutrition? And so this is really challenge. And also business point of view, recently you might have heard Norwegian salmon industry has lost $4 billion, over $4 billion just because of this COVID-19. Imagine how much is this? And then USA, so many other companies, even Thailand, also Thai Union, CP companies are losing. So this COVID-19 has caused so many job losses. Economic crisis is coming, maybe food crisis is already happening. So these three big problems we have in front of us. And it has given so much social unrest, suicide. You can see in USA, every day something is happening. That's why we have to adapt or mitigate the problem. And we need a lot of actions to mitigate these things, so that we have more job created, or food and nutrition, people will get enough, and also income in terms of poverty. So all these are like a SDG 1 in terms of poverty, SDG 2, SDG 3, and a job is like SDG 8. So aquaculture or fisheries side, we have to have a clear vision of what we can do, taking this problem as an opportunity. And many people don't know seafood is #1 item among the protein sources, more than chicken. Many people think chicken is #1. Actually not. Seafood, you look at the data, FAO data, Food Outlook, recently published in 2020. And if you divide this one by our population, 7.6 million, our per capita consumption per year is about 20.5. It is calculated from this. So, and also the seafood, out of that, 37% is traded between the countries, which is highest among all food items they produce. Like a second comes 23% of the production of wheat is traded, but seafood is 37%. What that means is seafood or aquatic food is actually contributing global food security. Some countries produce more and export to the countries where they cannot produce. That's why we have, this sector has a big role to play, not only within the country, it's globally. But problem here at the moment, all the interruptions because of the COVID-19, and people are becoming a little bit of more smart and having some sort of online sales. This is in Thailand. Also, Grab Food is selling a lot. All the super malls, stores, they are actually supplying home-to-home delivery services. So they have to give extra services. This is happening. So at least to adapt or mitigate the problem. And this is example in Kenya, one farm actually providing delivery service to home or door-to-door. And we need something like this. This was actually earlier one. They are selling live tilapia in the Philippines, door-to-door. So this type of facilities, system and business maybe is a potential there to run. And also processing things like after harvesting, fresh fish is difficult to take to different places and keep longer time. But if you have simple something like this, I'm sure in Indonesia also you have, this is in Thailand, you're simply using a hot air oven, hot air fan. Air is hot already, actually the fan is just sending the air. hot air to the fish, and fish gets dry, and then this can be kept a little bit longer. So domestic, local indigenous knowledge technologies are also useful to make something like this sun-dried tilapia, sun-dried fish, anything smoked and pickle and paste powder and canning or frozen fish nowadays. These can play a lot of role to make sure people have food in a remote area where they cannot produce. So instead of just focusing on production, probably processing and packaging things also can be very, very helpful. So I'm here again, my expertise on tilapia. So I'll be focusing how tilapia could help among the aquaculture species. Overall, all aquaculture has a similar role, but nowadays this fish is becoming very popular. That's why I wanted to give a little bit more emphasis on this species, because it can be cultured in many, many types of systems, cages, tanks, ponds, or raceways, whatever. And also there are so many types of genetic improvement, gift tilapia, chitlada tilapia, salina in Indonesia, I think for saline water they have developed already, and there are so many others. And also you can export if you produce this fish. So especially Nile tilapia in Thailand has been very popular. It is the #1 fish. It was actually catfish, hybrid catfish, but now Nile tilapia has taken over since mid-90s because of the technology and then promotion by the government. So it is considered as a king's fish. Originally, Thailand got from Japan. Emperor of Japan got the fish as a gift from the king of Egypt. And finally, I also knew that king of Thailand, former king of Thailand, has given to Sultan of Indonesia. So tilapia has been the gift of the royal families. And if you look at the global production, tilapia has been #1 actually when you compare each individual species, not as a group. And tilapia, including the red tilapia as a part of the Nile tilapia, it's a hybrid, right? So it was grass carp earlier, #1, but now Nile tilapia and its hybrid is taken over actually. And it is about 7 million metric ton per year, which is higher than salmon, higher than shrimp, almost all the species. That's why people don't know much. Now this is growing gradually, okay? Now this is the chance we have this opportunity in aquaculture or tilapia farming. This is the picture on celebrities, singer, dancers. They used to have a big performances. They used to earn a lot of money, but those group activities have been stopped. Now they are out of job. So many of them are actually doing agriculture or fish farming. So this is one example. So what I mean is we have to be smart to show the model how this agriculture and aquaculture fish farming can give the job for them and how much they could earn if they invest. So this is the right time to catch the people, their attention and their investment, because many of them actually have money, so they could invest a lot. So this sector has a great role to play. Well, some of the examples I'm giving here from Thailand, this is a pond. One pond is like a 9-hectare, 8-hectare pond. A simple farmer is doing two ponds, producing like 100 tons of fish, earning something like $100,000 per year. These type of things are happening. And also people could do a little bit of high production. Recently, this USEC, United Soybean Association, Export Council actually, is promoting this. Actually, it was designed by the Auburn University in USA, and they are promoting this all over the world. Pakistan, Thailand, Vietnam, China, they have got some success model. So they suggested here, you create a raceway here using a pump and recycle the water. So here you keep the fish and you feed as much as they eat, and uneaten food will go out and fish will eat outside where they are. So here, I think they are producing like more than 100 kilo per cubic meter, whereas simple RAS produces maybe 20 kilo, 30 kilo, 40 kilo only. So maximizing production is possible. And another system, biofloc, I think Indonesia is leading actually. A lot of biofloc systems are there for tilapia, catfish, and some pangasius, other fish. I don't know how many farms are there. I think data are not available, but production has gone very high because of use of biofloc systems. So we should try to utilize this one, do more research, and many other countries are trying, but there are some failures also. Some people cannot because it is not easy to balance the water quality parameters and probiotics and 24 hours ARS and all these things is not easy, but some success is there. So if it is successfully done, it can be done in a small place. That's why people are interested who have no land. And also you can have like a greenhouse where you can control the temperature during winter, or in some places where you have like a cold winter. So it is suitable for those places also. For example, here you can see in Iran, when I visited here, this is the man who came for training in Thailand here, and he went back and he did his big biofloc system with the cover with the plastic, because they have very cold winter and very hot summer. So they have to control all throughout the year, but it has done very well, and he has a tilapia hatchery as well. And also it can be done in a small scale, family scale. This is our project in Nepal, so family level farming. And then also with the vegetables, and in Bangladesh, they do a lot of vegetables evolve and nearby the pond. So people have, vegetable also, fish also together. Rice is cheap, so rice they can buy easily. But fish and vegetable, if they have, food security can be assured. And these type of things also family level. Now people are locked down, sometimes they cannot go out. That's why this should produce food at home. This is we call kitchen pond. So you just take the fish out and cook here. This is the quarters of the professors. They did it. And you can have like a 200, 300 fish, small fish, big fish, and you catch the big ones, and then small would get bigger. And then per week we are supposed to eat maybe 2-3 times. So 2-3 times a week, if you have a fish or any animal meat, will be sufficient. So you need a 200 to 300 fish is not difficult to have in a small place like this. Similarly, aquaponics, having a fish in a small tank, and also vegetable, you just need a small pump to recycle the water. It can be in balcony or rooftop, anywhere. So this type of models should be highlighted so that people who cannot go out from home, they could still produce their food at home. So simply aquaponics, everybody knows the principle. You have a vegetables, you have fish, recycle the water, and then nowadays what people are talking about, the immunity. You can grow like a garlic, ginger, or any spices which have which give us immunity. That is also important. Maybe we can highlight these things. We need more research. Most of the aquaponics systems use lettuce for salad, but Asian vegetables we don't have much research actually. So I would say I would request to do more research on this. This is one example here how we could do. And this is actually from Indonesia. USAID project did somewhere, I don't know exactly where, but I think USAID project wanted to utilize the water, because rice is everywhere in Asia. If rice needs water, then in that water, if you can utilize, especially tilapia can grow very well. And then because rice cannot provide everything, even some people are reluctant to have a rice all the time. It's a carbohydrate, so we need a protein and some vitamins and from vegetables. So this is in Vietnam. What they did is, this was a rice field earlier, so they could not survive with the rice only, so they converted to fish farm and then vegetable and food together, so they can utilize vertical space. There are four levels here, 4 layers: fish underneath here, and ducks here, and then vegetable, and on the top is a fruit. So with this, they can earn enough money to survive for that family. In Vietnam, communist government gives maybe 4,000 square meter land for each family, so they have to survive with that land. That's why they have to maximize the productivity. This is example in Thailand case culture. In the Mekong River is so turbid, but it's still tilapia can survive. So it's a hardy fish. People are doing use scale with the demand feeder. And one case produces about nearly 1 ton fish. So around $1,000 they can earn profit. And this is our recent project in Cambodia. So this lady came for training and they did already hatchery and case culture. And actually in Indonesia, there is a one good example. I think Regal Spring, American company is having a big case culture in lake, but most of the tilapia is, for export to USA. So I don't know how many other places this has been, transfer this technology, probably not happening some places. So I think there are many places it could be done. But nowadays in other countries, even in Malaysia, they are doing big cases. These cases are actually used for salmon industry. Now tilapia industry is using this to produce bigger volume because of the demand, high demand. And also recently in India, in the past, India did not allow even tilapia. Now they are doing tilapia and also culturing in cases in the lakes. You can see tilapia is everywhere, barbecue or even already ready to eat, like a steamed one and deep fried and live tilapia. So in Thailand, it is very, very common now. So from food security point of view, it is playing very big role. It's a cheap fish, so everybody can afford it. In the past, it was considered poor man's fish. Now everyone's fish. So in the supermarket, you can find very high quality, even bio, something organic things. Then they charge even up to $7 per kilo. So which is almost like in UK, like you see, this is Indonesian tilapia in UK, £5 per kilo. So there is happening something, but I don't know, how many people are involved in tilapia industry. Although Indonesia is second to the after China in producing tilapia, but probably mostly that one company is producing more, dominating. And also tilapia is used for other purposes like McDonald's. This is from Indonesia. I found somewhere, and I think in Bali or somewhere this picture. And they are using tilapia as a fish or fillet. Earlier they used from other species, but they found tilapia is suitable. So people could not differentiate. And imagine if McDonald's all over the world use tilapia, then the demand for tilapia will be huge. And similarly, other chain restaurant, chain markets use that one, and demand will be huge. So main thing is you need a seed production technology. I think grow out technology is already there. Some more research and more seed is the main thing. That's why AIT did a lot of research on seed production system to develop using HAPA-based systems. So under this system, we collect the eggs and different based on the developmental stage and incubate them in simple jar like this, plastic jars. And this technology was commercialized. This company, he's the manager, is running as a big commercial scale. You can see one jar can have like 1 kilo. He has maybe hundreds of jars like this. So, and this is another hatchery. This hatchery has 1,000 jars in a single place. Imagine how much they can produce. Like one jar can have 100,000 eggs. You multiply by 1,000 jars. It has a capacity of 100 million eggs to keep at a time. So this type of scale going on in tilapia industry. Because of the hatchery, production has gone high, and these hatcheries are not only producing for Thai farmers, but they are exporting to all over the world. Okay, so the hatchery has a big role to play. You can see this single tray has something like a 20,000 in small larva to rear here. So this is AIT facility. I did research long time ago. Imagine if you have like this single pond, 10,000 per hapa. How many here? Millions of fingerlings you can produce. This is actually monosex system, monosex fry. So farmers can get very fast growing fry from this system. So we organize a lot of training. People come from Africa, from Australia, from Norway, India, Fiji, all over the world, people are coming for training. And then they are going and doing things that way. From Indonesia, also a couple of came, but I'm not sure how many. So this technology is going all over the world from AIT. And we do a lot of other collaborations for project, like at the moment I'm coordinating EU project. I think we have 3 partners from Indonesia, and then University of Riau also supposed to be here, but somehow we missed it. So we'll see in the future, hopefully we can have more collaborations on these. Thank you very much.
Okay.
Conclusion, what I wanted to say is COVID is a really problem, and then tilapia aquaculture has a big role to play. But we need more collaborations, especially for hatchery technology, and then maybe processing other things. Okay, thank you very much.
You're welcome. You're welcome, Dr. Bujil. It is very entertaining because that one is very applicable for our real farmer. And food security is an issue that must be overcome, because after we suffer from the pandemic, we need to provide more food for our society. And fish is one of the best sources of food that can be provided, because it contains many compounds that is very good for our immunity and so on. Yeah, once again, tilapia is an easy species to be reared by our fish farmer, and also it is very well recognized for many different countries, even in subtropical countries as well. Yeah, we have learned that the malnutrition is a big issue, and then the stunted growth of population, including Indonesia, due to the malnutrition issues. And also, according to his calculation, Dr. Rambujil able to calculate that 132 million people will suffer from this pandemic and due to the short of food. And then one of the study has found that $4 billion has lost from salmon industry, for example, in Norway. So aquatic or seafood or aquaculture is one of the solutions that can be chosen for ourselves. And he said that tilapia is a special fish because it is not only related with the real people, but also even in the past, it was involved in royal custom. Yeah, it was used as a gift from one king to the others, from Egypt and then Japan, Thailand, and Indonesia. Yeah, he proposed many models how to produce the tilapia. Yeah, for example, from the US invention, he mentioned about IPA model, and then from Indonesia on the other countries like backyard biofloc, and then rice farming, integrated farming, aquaponics, and so on. Yeah, and he proposed also we can provide the fish product with different forms. So the baby on the children will able to enjoy the source of protein without disturbing the way of on the habit for eating. Yeah, I think that's what we can learn. And once again, thank you very much. Thank you very much, Dr. Rambujil. And I would like now to invite the third speaker by the name of Dr. Nurul Huda. He is working in Kinabalu, Sabah, in University Malaysia of Sabah. And his title today is Utilization of Byproducts from Tropical Marine Fish Surimi. And this is related with his interest in marine science and fisheries affairs. From his CV, I could learn that he works a lot for making the products and also producing the papers for fish products technology. Dr. Nurul Huda got his bachelor degree in 1987 from Bung Hatta University in Padang, West Sumatra, and he got his master's in 1994 from IPB University. Yeah, in the past it was called IPB, yeah, Bogor Agricultural Institute. But since last year, the rector declared that now it has new name, Bogor IPB University. Yeah, and also he got his PhD in 2001. Before I allow him to talk, I would like to thank for the participants. Now it's approaching 116, and the participants coming from all over Indonesia. So from the west, we have Ibu Erika Pardede from Nomensen University in Medan, and then Pak Andreas Dipi Patria in Jakarta, and then in the center part of Indonesia, we have Pak Suleiman from BAPPP in Marosot, Sulawesi. And also from the east part, we have Ibu Ratna from Muhammadiyah University in Sorong, West Papua. Okay, Alhamdulillah, yeah. Now, please, I would like to give the opportunity to Dr. Nurul Huda. Time is yours, Pak Nurul Huda. Silakan, Bapak.
Okay, thank you, Pak Joko Samiaji, for the opportunity to me to share some my experience in the field of the fish processing technology. Hello, Dr. Ram. Nice to meet you again, Dr. Ram. I hope you still remember me. We met last year in UGM in Yogyakarta for the International Conference. Okay. First, I would like to present my gratitude to the organizing committee of the conference for inviting me as a speaker for this global seminar. So can I share my slide, Pak Joko?
Yes, dear Ibu Trisla.
Okay, can I say so let me share by myself. Let me share by myself.
Okay. Yes, I see you. Yes.
Okay, can you see my slide?
Okay, yes. It's beautiful garden, yeah, beautiful park.
Okay, thank you. I think I'm sorry, Dr. Ram, maybe I need to mix my presentation some with Indonesia to make me close with the participant, because as informed by Dr. Joko, most of the participants from Indonesia, maybe for some term I will deliver in Bahasa Indonesia, but the slide then provide in English. Okay, the title of my presentation is utilization of byproduct from tropical fishery. I try to inline with the seminar theme related to for the achievement of the sustainable development goal. In line with the SDGs number 12, responsible consumption and production. So actually, this slide is provided together with my PhD student Abdul Aziz Jazri, who currently under my supervision here for his PhD program. So I'm come from University Malaysia Sabah. I think for some of you which not really familiar with University Malaysia Sabah, so let me the location of the university. So the location of the university is at the top, the peak of the Borneo Island, ya, di Pulau Kalimantan paling atas, ya, di Pulau Kalimantan atas itu kita ada University Malaysia Sabah. So actually we have 3 campus. Kita ada 3 campus. One is belong to Kota Kinabalu campus. Second one is belong to located in Sandakan, and the one is in Pulau Labuan, special dedicated for the Faculty of Finance. So the Faculty of Finance is located in Pulau Labuan. So I think the near university with us is the University Borneo Tarakan. So then we already consists is around 1,000 academic staff, and number of students is around 17,000 students for undergraduate, and around 2,000 students for master and PhD student. So kita bersyukur ya, because kita ada pretty good campus, so we have a very good environment in our campus, blue sky and pretty clear sea water. It looks like it's a paradise here. So in this seminar, I try to invite of the participants. Maybe after the COVID is end, maybe try to come to pay a visit to UMS, and then you can enjoy with the beauty of the Sabah. So this location is a campus is surrounded by sea. So you can see from this map. So actually our campus is near to the sea, to the sea. And then we can normally after afternoon, some students enjoy go to the beach, yeah, for make them happy. And also we have some small mountain for some activity. So actually, I'm from the Faculty of Food Science and Nutrition. We have 11 faculty. We have 4 Center of Excellence and also 3 center. So we also have some research unit related with some different field in our university. So I would like to give my email address to all of the participants, because I love to collaborate. Jadi suka bekerjasama dengan kawan-kawan di tanah air. So maybe I can help, or maybe I can share some of my experience with you. So please not hesitate to contact me. My email address, and also you can please feel free to WhatsApp me in this number. So this is the outline of my presentation, introduction, pengantar, and kemudian utilization of topical fish surimi by product. Because I will focus on the surimi by product. It is to in line with the SDGs number 12 and then followed by the value of the topical marine fish by product. And then I will continue with the value-added product that we can produce from the topical marine fish surimi by product, and continue by the bioactivity peptide that can derive from the surimi by product. So I will close my presentation with a challenge and future outlook of the topical surimi by product. So ini adalah, I think is common now. Mungkin some of you, because all of belong to Faculty of Fisheries and Marine Science, the production of fish, whether from marine or aquaculture, increase yearly. From 1961, you can see from 1950 to 1918. And then the consumption per capita is also increased, yeah, among the people. So but maybe the different only starting from 1999, the production from the marine fish a little bit tidak naik, ya. So more production from the aquaculture activity. The consumption also increased. If we can see from this graph, approximately in 1950, the consumption of the fish per capita is around 9 kilogram per person. But for this time being, to the statistic for 2 years ago, the average fish consumption is reach around 20 kilogram per capita. Apa arti di sini? Di sini kita dapat mengartikan bahwa peningkatan pengambilan ikan ini memang terjadi setiap tahun. Jadi kita mesti memahami bahwa konsumen akan selalu mencoba untuk mendapatkan sumber protein daripada ikan. Tapi dari semua ikan yang kita tangkap ni, it's not 100% we can process efficiently. It's around 35% of the fish that we produce is belong to the West, meaning every year is around 46 million ton of the fish is discharged. Jadi ini yang terbuang, which considered to by product, and then we need to pay attention for this huge number of the byproduct that produced from the marine or wastewater fish. This one is related with the what do you call it, the Sustainable Development Goals, by number 12 for responsible consumption and production. So meaning as a scientist in the field of the fisheries and marine science, we need to think how to utilize, how to use this huge amount of the byproduct. 46 million ton is not a small number, very, very big number. And then we need to contribute to reduce this huge number of the product and convert to more value-added product. So let me explain a little bit about the surimi. I think for some of the lecturer which are from the fish processing, quite familiar with the term of surimi. Tapi mungkin saya akan ulang lagi pada surimi ini. Surimi adalah konsentrat daripada daging ikan yang menggunakan mechanical debone, because we deal with industries, meaning we need to separate the flesh from the body of the fish using the mechanical deboner, and then we need to conduct the water washing in order to separate, to remove the blood, to remove the sarcoplasmic protein, pigment, and etc. And then we need to mix with cryoprototan in order to maintain the functional properties of the fish surimi during frozen storage. So in this within this surimi form, and then we can keep this fish protein for a longer time without any significant different in terms of the functional property. Jadi dalam pembuatan surimi ini kita akan melakukan 3 tahap: meat separation, washing, cryoprotein adding, dan frozen freezing step. Dan surimi ini adalah berasal daripada Jepang, ya, daripada Jepun, ya. Surimi ini berasal daripada Jepun, kemudian dibawa ke US, kemudian dikembangkan di seluruh dunia. So actually syarat requirement for field for suitable for the surimi production adalah dia mesti ikan-ikan yang berharga murah, which consider underutilized dan less utilized fish species, ya, supaya kita dapatkan some profit there. So meaning we need to deal with underutilized or low economic value of fish species. So kita kalau ikan yang sudah mahal seperti ikan salmon, ikan tenggiri, we no need to think to process to produce a surimi from this kind of fish species, because this kind of fish is considered as expensive fish species. So for surimi, we need to use from underutilized or less economic fish species. And also because we deal to the industrial scale, kita mesti ikan yang ada itu mesti dalam jumlah yang banyak, and need to come with abundant resources, ya, to permit much production. And also the fish species must come with very good functional property, as well as white flesh flour with and also subtitle flavor and odor. Jadi bau dia mesti tidak berbau kuat, dan warna daging adalah warna daging yang putih. Kalau ikan itu adalah ikan yang berlemak tinggi, come with quite high fat content ataupun color dia jadi gelap, and then we need to modify the process in order to produce surimi. Meaning we still can produce surimi from the high or moderate fat content of fish species or fish species with a dark flesh color. Ini adalah Professor T.C. Lanier. Actually, as mentioned previously, the surimi technology originally from Japan. Yeah, and then by 1970 something like that, Professor T.C. Lanier brings this technology from Japan to US, and then he developed this technology US and then spread to around the world. And then for this time being, the most popular scientist or in terms of the surimi is belong to Professor J.W. Park. But actually, Professor J.W. Park is a former student of Professor T.C. Lanier. I'm quite lucky because I had an opportunity to meet with both of them during my visit to US a few years ago. So ini adalah dia punya ikan-ikan yang biasa digunakan fish species yang digunakan for the production of fish species. So most of the fish species previously belong to temperate from the temperate region, such as Alaska polar, northern blue whiting, Atka mackerel, Pacific whiting, jet mackerel, southern blue whiting, dan hoki. Jadi ikan-ikan yang berdarah dari 4 musim, ya. Tapi ada juga dimulai trap fin. Jadi ada ikan trap fin atau ikan kerisi adalah ikan-ikan yang mula dikembangkan untuk menghasilkan surimi. pada awalnya in the early stage of the surimi industry, around 60% of the surimi come from the temperate fish. But for the current situation now is around 60% from surimi production belong to tropical marine fish. Maknanya makin banyak ikan surimi dihasilkan daripada ikan-ikan yang berada di daerah tropis. Tapi ini juga membawa satu tanggungjawab kepada kita untuk memikirkan bagaimana tentang penanganan daripada sisa ataupun limbah daripada pemprosesan surimi ini. So ini adalah di punya production of surimi as I mentioned earlier. Previously yes, 30% of the surimi production is belong to tropical marine fish, but for this time being is around 60% daripada what production of surimi belong to tropical marine fish. Jadi sumbangan kontribusi ikan-ikan tropis terhadap dalam penghasilan produksi surimi ini sudah dominan dan mencapai 60%. Dan inilah jenis-jenis ikan fish species yang biasa digunakan untuk penghasilan surimi. Ada ikan tiat frame, crazy, lizard fish, big eye, quaker, godfish, ponyfish dan juga yang ikan lain. Inilah what you call it the flow chart for the production of the surimi. So you need to conduct the heating and coating, gutting to remove the heat and also to remove the internal organ of the material. And then we separate the flesh by using the mechanical deboner. And then the flesh the meat we need to proceed with some washing treatment in order to separate the blood and all of the sarcoplasmic protein. And the rest which belong to the myofibrillar protein, we need to conduct some training in order to reduce the number of sarcoplasmic protein and also reproductive tissue. After that, we need to mix with cryoprotectant in order to permit to avoid the changes during the freezing and also during the stress. So within this process, we can maintain, we will able to maintain the functional property of the fish protein for longer time. Can be one year, it can be more than 1 year, and then we can apply it to different product which belong to surimi-based product. So ini adalah dia punya byproduct in general, byproduct yang bisa kita hasilkan daripada ikan. Jadi daripada isi ikan itu kita bisa mengambil protein of course, dan also dia punya minyak dia. Form daripada skin dan fin dia, daripada kita boleh proses menjadi kolagen dan gelatin dia. Belum backbone dan ton dia ada mineral, kita boleh membuat fish bone powder juga kolagen dan gelatin. From the viscera we can extract enzyme, oil dan juga protein. Dan daripada kepalanya kita juga boleh extract oil, hyaluronic acid and also some peptide. Ya. Jadi normally during the production of the surimi, bagian-bagian yang diambil itu hanya bagian flesh dia saja. Bagian kulit, bagian tulang, bagian fin, bagian internal organ, bagian kepala itu dibiarkan sebagai limbah atau sisa. Is around 60% daripada the body part of the fish species is considered to byproduct. Dan ini yang kita perlu fikirkan bagaimana menggunakannya. As mentioned purposely, ini adalah normally fish species yang biasa digunakan for the production of surimi. And then around 60%, at least 60% daripada bagian itu adalah belong to byproduct atau belong to waste material. Then we need to think how to use this kind of the product. Otherwise, maybe we need to throw out to the sea and become pollutant, meaning we have problem to execute the SDS number 12 for responsible consumption and production. So in order to proceed to fulfill, to achieve the SDGs number 12, we need to think how to use this kind of the byproduct. So we can use this kind of byproduct which consists of scale, skin, internal organ, bone, flesh, and heat to two type of the product. Whether belong to conventional product or belong to non-conventional product. So for conventional product easily kita boleh mengubah dia, memproses dia daripada sisa ini menjadi tepung ikan, kemudian digunakan sebagai makanan hewan. Or maybe we can conduct silage to produce fertilizer. Or maybe we can use to produce fish snack. Kulit ikan kita boleh go to produce fish snack for human consumption. But we can also put some more effort to produce more value-added product by using some technology. We can produce a collagen, or we can extract the enzyme, or we can produce a protein hydrolysis. So maybe this presentation will focus to production of the non-conventional product, especially for the protein hydrolysis, because protein hydrolysis will come with very specific properties such as antioxidant, anti-hypertensive, anti-anemia, and also for proliferating product. Ini kalau kita melihat ya, kalau dalam operasi surimi, maka dia akan menghasilkan sisa. So ini adalah data for my student, the detailed function and weight of the lizard fish surimi byproduct, ini daripada ikan lizard fish ya. Jadi kalau dalam pabrik surimi, ini adalah limbah dia. And then kalau we separate the byproduct, it consists skin is around 25%, fin around 22%, flesh, jadi masih ada daging yang bisa kita kumpulkan di sana, is consists around 22%. Kemudian tulang dia ada around 18%, dan scale dia, sisi dia dalam 30%. So ini adalah dia punya what you call the detailed function of the byproduct from the surimi industry, dan ini yang kita perlukan. We need to think how to use this kind of byproduct. So ini adalah some data, published data related with the nutritional value of the typical marine fish byproduct from the surimi processing. So you can see, I want to highlight this one. All of the byproduct is consist high protein content. Jadi proteinnya masih lagi tinggi di sana, and then meaning we can use this kind of byproduct to produce whether conventional or non-conventional product, because the protein content is quite high. Some of the products also consist quite high fat content, and then especially from the muscle, and then we can extract maybe some oil from this kind of the byproduct. Maknanya limbah-limbah yang terbuang ini bukan merupakan sesuatu yang tidak bernilai gizi ya, tapi dia punya protein content is quite significant, and then we need to look how to use this kind of the product to become better product, not only for the material for the animal feed. Ini juga ini adalah beberapa value-added product that we can produce from the byproduct of the surimi processing, such as we can extract enzyme from the liver. So from the surimi product, we can also produce a collagen and a gelatin, and also we can produce some protein isolate from the surimi byproduct. So and then this one consider quite a good way to produce value-added product from the surimi waste material, better than if we process only to produce fish meal. Apa yang mungkin ingin kita lihat lagi adalah di punya food application dia. So the product we can apply to different food product. Such as kita akan boleh apply protein hydrolysis from the cream byproduct, because mentioned purposely for the byproduct also consists some flesh, is around 20% of the byproduct still belong to the flesh, and then we can use to produce the hydrolysis, dan kita boleh gunakan sebagai flavoring agents dalam bubur ya, dalam bubur nasi. We can also produce what you call hydrolysis protein from different fish species, such as here we can produce from the different type product, and then also different application of the product, such as for lard product, apple juice. So bouillon cube, we can produce a bouillon cube from the byproduct of the cream, as well as we can use as ingredient for the production of the chicken ball. Ini mungkin yang harus kita perhatikan. So we need to put some concern from this food recovery hierarchy of this byproduct. The easy way to treat the byproduct adalah jadikan dia sebagai untuk tanah saja, untuk feed material or material for the animal feed. But we can put more effort to produce better product and then to maximize the yield of the yield and the quality of the product by using some technology that later on we'll discuss and describe. So ini yang mungkin saya akan highlightkan the bioactive compound that we can produce from the surimi byproduct. So such as a compound with activity with present the activity as a polypolyradiative or anti-anemia, antioxidant, antibacterial, antihypertensive, and so as a product with wound healing activity. So it is this kind of the products that you can produce from the surimi byproduct. Most of the previous report only focus for the production of the hydrolysate protein with good antioxidant activity. So meaning for the waste material from the surimi processing, we can produce hydrolysate protein with high antioxidant activity and also with high SA antibiotic activity. Normally, because most of the topical surimi is belong to the terpene cream, so you can see from this table, most of the report is working on the byproduct from the terpene beam of QC or Nematodes japonicus. So some report using the BI snapper, but most of the result is focused on antioxidative activity. Jadi sebagai antioksidan ya yang banyak dilaporkan. Masih belum banyak lagi laporan yang menggunakan sisa surimi ini sebagai bahan untuk pengobat luka atau sebagai bahan sebagai anti anemia atau bahan sebagai antihipertensif atau sebagai anti microbe. Most of the previous result, most of the previous report is focused on the production of the protein hydrolysate with high antioxidative property. Ini mungkin if you remember mungkin 3 to 4 years back ada some report ya how the Brazilian doctor try to use fish skin to treat the victim from the accident by using the this time they use tilapia fish ya untuk merawat orang yang luka ataupun yang terbakar. So meaning we can use this kind of fish skin as a wound healing agent, wound healing material ya untuk mempercepat penyembuhan daripada luka dengan menggunakan collagen daripada kulit ikan. Ini adalah dia punya waduclad yang mungkin we need to think how to produce a byproduct because as mentioned previously the skin also quite significant number we can extract, we can collect from the surimi byproduct. And then this kind of skin we can use as a material for wound healing, not only for human but also for the animal. Ini adalah report-report yang 3-4 tahun lepas ya, bagaimana doktor coba menggunakan directly the tilapia skin untuk mentreat orang yang terluka ataupun termakan. But we can produce the collagen hydrolysate from the surimi byproduct in order, and then we can determine the ability of the collagen hydrolysate for the wound healing effect. So ini adalah laporan, but most the report dia ada untuk ikan-ikan yang ada di temperate region. Very less, almost none report related with the wound healing activities of the topical marine fish, especially from the byproduct. So you can see here from the report by Zheng et al. 2011, they use the skin, the skin of the salmon and then to treat the animal with some wound healing. And then you can see this one, the collagen from the salmon skin is able to treat the wound healing as a wound healing effect. Also, the similar report by using the Alaska polar, and then you can see the flesh protein from the Alaska polar is able to come as an alternative way to treat the animal with experience with experience. So the healing rate of the flesh from the Alaska polar is much better than the standard vehicle which belong to the sterile saline. I think before I close with my presentation, this one I just to attract attention from the participant is very important for us to think to find a way how to use a byproduct to produce the high quality added value product, whether with anti anemia or anti oxidative or anti microbe, or is possible with a wound healing activity in order to relate in line with the SDG number 12. This is my the last slide is my student who currently work with me as for the utilization of the surimi byproduct to produce wound healing alternative. Is that I think I close my presentation, Dr. Joko.
Yeah. Oh, very nice picture. Yeah. Okay. Thank you very much, Dr. Nurul Huda. It was very interesting presentation, and we learned that the byproducts of fish can be used for making surimi, and even you said that for anti-wounding, yeah? It is really useful, yeah? So from now, we must not throw the byproducts of fish, yeah, because many of us only eat the meat and then the rest will be discarded, yeah. And there are many alternatives in making surimi, and mostly coming from the cheap fish, yeah. But in my area, in where I'm sitting now in Tapanuli Tengah Regency, near Sibolga, expensive fish such as barracuda is quite ample, yeah. So we can make it as materials for making surimi as well. And once again, this is also related with the presentation from Dr. Rambujal. I think that this is to overcome also for food security. Yeah? So we must diversify the forms of food that can be available in the market, and also for the kids, I think. Yeah. Thank you once again, Pak Nurul Huda. Sangat menarik, dan insya Allah kita akan ke Sabah kalau Bapak undang nanti ya.
Iya, insya Allah, Pak Joko. Please.
Campus is very beautiful, I think. And I think that there are many similarities between Sumatra and Sabah, so we can make the collaboration in aspects, I think. Oke, terima kasih Pak Nurul Huda. Selamat istirahat sejenak, and be prepared with answering the questions from the participants. And for the participants, please hold your question. I will give you a time later after Pak Sofyan presenting his topics, yeah. And I will tell you by sending the message how to deliver the question, yeah. And now we come to the fourth presenter, and it will come from my colleagues, Dr. Engineer Sofyan Hussein Siregar, MSc. He did his undergrad or bachelor program in IPB or IPB University in 1991, and then he continued the master degree program from Newcastle upon Tyne in the UK in 1996, and then he proceeded into the PhD program from Kyoto University in Japan and finished in 2002. His research focus is mainly with the marine diatoms. So today he will present his work on biodiversity of diatoms in Sumatra, Indonesia. In daily life, Pak Sofyan active in environmental impact assessment, both for freshwater and marine water ecosystems. And at administrative affairs, he act as the vice dean for the academic affairs before, and now he is the vice dean for collaboration and also student affairs. And he involved in professional activities, for example, in diving association, Red Plus, and so on. So here, please receive warmly our colleagues, Dr. Insinyur Sofyan Hussein Siregar, MSc. Pak Sofyan, time is yours. Halo Bapak. Pak Sofyan.
Udah Pak. Coba Pak. Itu dia di share. Jangan dulu, bisa buka langsung tadi. Dia mau di share langsung Pak. Iya. Dibuka dulu. Udah. Enggak, jangan gitu. Nah, enggak ininya supaya aku mana dia? Tadi pikir udah ready. Slideshow.
Tolong dibantu panitia.
Tidak pikir mau ready.
Halo.
Mana ini yang lanjut? Itu kan slideshow. Dibuka dulu slideshow dulu.
Halo.
Ulang dulu. Sudah belum lagi spesial. Gimana caranya saya nggak ngerti. Spesial lagi belum lagi saya. Oh ya. Oh ya. Yang sudah harus itu dulu dia dibuka dulu tuh harus. Jangan dulu gini. Dibuka dulu dia udah dibuka duluan di sini ya maksud saya. Di mana di sini? Di D. Ini nggak tahu tadi di mana ya. Saya pikir udah ready. Kamu dari tadi kamu ready. Kok bisa dibuka ya? Slideshow-nya. Oke. Udah lagi dibesarkan aja ini udah. Jadi kayak gitu nih. Oke, ya, ke atas lagi. Ya, ini nggak bisa turun naik. Oke, ya. Okay, I'm sorry, there's still a bit problem. First of all, I would like to say hello to all international seminar participants. Even though this is the last session, hopefully you will keep going on. On this occasion, I would like to present my topic is about the biodiversity of diatom in Sumatra. Of course, before I continue this presentation, I would be nice if we know what diatoms are. Diatoms are many members of algae class Bacillioraceae, division of Chromatophyta, and maybe either unicellular and colonial. One of the uniqueness of diatom has a cell wall of silica. In detail, the silicate cell wall forms a pillbox-like cell crustule composed of overlapping valves, epitheca and hypotheca, read by integrated and delicate patterns. Okay. Due to its diverse and unique shape, diatoms are often referred to as a jewel of the sea. Besides that, diatom can be found in the ocean, waterways, and soil diatom life as a plankton, attached to benthic substrates, floating debris, microphytes, and other objects. It can be found also as extensive fossil deposit. In other words, diatom can be found all over the world in many types of ecosystem and able to attach in many types of immersed objects. Of course, there is a specific diatom characteristic. First, very sensitive to change in water quality. And also very fast respond to the environmental changes. Next, their life cycle are short compared to the other organisms, such as a fish and macroinvertebrates. And also, diatoms has quickly reproduce in their reproduction. And diatom can be found in almost all substrates, are able to record change in the habitat. According to the diatom characteristic, we can say also diatom can be found in many types of habitats in great range of environment. Some specific diatom may be found in the specific habitat. Diatom can also be used as an environmental indicator. For example, for indicator water quality, some diatom can be used a bioindicator for anthropogenic pollutant and so on. In their lives, diatom we can divide into life. The first is planktonic diatom, and the second is based on to this attachment site, or we can say also diatom attachment. Based on its attachment site, diatom can be classified into type, namely, as we can show in this slide, there are 7 type of diatom attached to some subtype. For example, epiphytic attached to the aquatic plant, epistamic attached to sand in a sand, epiphytic attached in sediment surface, endophilic living in the subsurface of sediment. Epiphytic attached into stone surface, and also epizooic attached to the in animals, and pollen attached in immersed object. In this, all of the diatom lives we can samples by various sampling method based on its habitat. As we can show in this picture, the sediment we can scraping or by spatula for this using the quadrant to know about the abundances, and also we can scraping by toothbrush from the mangrove trees. As usual, for the planktonic, we can sampling by plankton net. Okay. In our study, already take some place in several in. In this time, I'd like to mention about that. Bengkalis waters. We'll take the sample last year, 2019. And so that we take the sample from 3 habitats. The first one is from the epiphytic diatom, second from the epiphytic diatoms, and the third from the planktonic diatom in Bengkalis waters. We can find that the number of species were recorded is the highest we found from the planktonic, and then the second from the epiphytic diatom, and the last the lowest is from epiphytic diatom. From three substrates, we can found that in the red color, there is 12 species are found in all substrates as shown in red color, and some species only recorded in specific substrate. For example, Amphora here, Amphora bidulfia and Thalassoria only found in the mangrove trees here. Mangrove trees. In contrast, we find also we take in the same substrate from diatom in Tanjung Pinang, and also we taken sample in 2019. In contrast here, the number of species, the highest in epiphytic diatom in sediment, and the lowest is in planktonic diatoms. Maybe it just depend on the condition of the location. Or in Tanjung Pinang is in this location maybe there is some pollution in some location when we take in sample, and the number of species. The highest number of species we can record it in this Tanjung Pinang waters, 21 epiphytic diatom, and 17 in epiphytic diatom, and 14 in planktonic diatom respectively. Next slide. Nah, maybe it's more important. This is the first time we study on epizoic diatom. And epizoic diatom attached to the in the snail of Syrtidae cingulata, or the snail of in the trees mangrove trees ecosystem. If we are looking in the tables, Amphora sp is the specific species. Amphora is the species example in the cell of Syrtidae cingulata. Okay, from this three location, I try to recapitulate the distribution of diatom in different location and substrates. From this table, we can show that we have 29 species diatom we recorded in three locations. Furthermore, there are 5 species. 5 species is in the red color also. 5 species we recorded in all location and substrate. For example, the Diplonis sp, and then Istimia sp, Navicula sp, Gicia sp, and Sinetra sp. The uniqueness of the in subtype, especially in epizoic. Epizoic only find in epizoic 2 species, Cyclotella sp, Simbella sp, and Scalotoma sp, only found in epizoic. maybe we can say that this species is a specific species in epizoic in the cell of the Ceratidae cingulata. We can say that this species maybe can be used as the bioindicator for the with symbiosis with the epizoic in a cell in the cell of the Ceratidae cingulata. Okay, then maybe I'd like to, maybe I don't have many slide. I'd like to conclude the our biodiversity in Sumatra. There are 5 species found in all locations, right? Namely, as I told before, and this is species are categorized as a cosmopolitan species because some the scientists said that especially Navicula and Nicea in merupakan common species we recorded we found in all over the water in the world, and there is a similarity tendency between epizoic and epipelic diatom species. If you comparing between epipelic and epizoic, it may be it may be because the epizoic also, especially the Ceratidae cingulata, live in sediment. Because they live in sediment, and also epipelic, we can take sample from sediment. That's why there's the tendency to the almost same some species in epizoic and epipelic in even though in the different location. And also Simbella sp and Cyclotella sp and Skeletoma sp, we can justify it as a specific species found only in the cell Ceratidae cingulata. In further research, maybe we can more specific to look the symbiosis associated between 3 these species in the cell of Ceratidae to know about the how important the relationship between the species with the Ceratidae cingulata. Maybe it is the diatom is very important for the next future in our environmental application and importance of diatoms. The first one is diatom cover a vast area of ocean so that the measure of the global carbon balance. Diatom contains chlorophyll. Of course, they are a major resources of atmospheric oxygen. It's very important things for us to maybe to maintain to about the abundances of diatom in the ocean. About 20 to 25% of all organic carbon fixation on the planet, transformation of carbon dioxide and water into sugar using light energy is carried out by diatoms. How we can imagine how the diatom can be more important in our environmental aspect. Now, for to Indonesia, of course, for the future research on diatom in Indonesia, according to my study, my student, maybe in the next year, in the near years, we can be focused on the relationship between plastic waste in the intertidal areas and presence of diatom. As there is now, right now, as there is a huge amount of plastic waste standard in the coastal area, and it may negatively affect to the coastal area in general as well the diatom habitat. this is very important for other research, especially to the plastic waste, because plastic waste through to the intertidal was maybe covered some sediment, and maybe will be disturbance of the habitat of in, especially for heavy pelling, and also is some plastic covered in the
Pak Sofyan.
mangrove trees. Okay, 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 and then okay. It's the time. This last slide. Thank you very much for your attention. Okay.
Okay. Thank you, Pak Sofyan, for your presentation on the diatoms across Sumatra beaches. So Pak Sofyan has reported 3 locations of study sites from Tanjung Pinang, and then Agam, and the other is from Bekalis, ya Pak ya.
Yes.
He found that there were many species which considered as the cosmopolitan species, and a few number of species also host specific species. For example, they attach to snails or gastropods. Yeah. Now it is the time for discussion, and I would like to invite participants to give the question, and please mention to whom the question will be delivered. And actually, I tried to make the rule for participants who will ask must raise his or her hands, but during the talk, I couldn't find that it is working for that. So just please tell your name, and then I will give allocation for 3 people in each section. So we will have 2 sessions for this Q&A session. Okay, thank you. Please.
Dr. Joko, I say hello to Satoshi Sang because I didn't see it.
Okay, you will ask him, or you just say hello?
Say hello because he already visit to Indonesia, but because this condition we have a research collaboration with Satoshi Sang, especially for diatom also. Yeah.
Okay. Okay. Yeah. Please, dear participants, would you give the question for 4 speakers this afternoon? Or you may raise your hand so I can recognize you, then give you the allocation to us. Silakan melambaikan tangan Bapak Ibu ya yang akan bertanya. Nanti saya akan beri kesempatan. Tadi ada Pak Fauzi dan dengan Bu Sabirina kalau tidak salah yang memberikan pertanyaan, raise hand sama ini ya, sama di chat tadi saya baca sebelum ada problem tadi. Pak Fauzi tadi mau bertanya apa, Pak? So, Pak Fauzi. Oke, then Ibu Sabirina. Ya, tadi Ibu Sabirina bertanya. Her question is for Dr. Nurul Huda ya. She asked about how to alienate, ya, how to eradicate the smell of the mud from the meat of catfish, ya. Bagaimana menghilangkan bau lumpur untuk mau diolah menjadi produk dari ikan patin yang akan dijadikan misalnya surimi gitu, itu kepada Bapak Dr. Nurul Huda ya. And the second question or comment from her is not all fish parts can be processed as the materials for surimi. Silakan Pak Dr. Nurul Huda ya.
Okay, thank you Pak Joko Samiaji. Okay, thank you for Ibu Sabarina Hasibuan for the question. The muddy platform related with the geosmin. So as indicator that the water quality is not good for the living of the species. Jadi di geosmin ini dia tidak, kalau ikan itu sudah mati, kita tidak ada any treatment to reduce the muddy platform, bau lumpur. So what we can do, we need to reallocate the live fish from the pollutant water to the more better quality water. Jadi ikan itu sebelum kita panen, kita pindahkan kepada air yang mengalir, air bersih yang mengalir at least 2 hari in order to remove all of the geosmin. Karena geosmin ini kalau sudah di dalam badan dia, jadi mesti dikeluarkan pada waktu hidup. Kalau ikan itu sudah mati, and then we never able to remove the existing geosmin karena dia akan terus berada di dalam daging ikan tersebut. Jadi it's a way to reduce the muddy platform ini only by treat the live fish, by reallocate the live fish to the better quality of water. Jadi kita mesti pindahkan ke air yang mengalir, itu paling tidak 2 hari gitu ya, sehingga semua geosminnya mengalir keluar. Karena muddy platform ini adalah as indicator bahwa perairan tempat hidup ikan tersebut itu tidak kurang baik karena ada geosmin di sana. Jadi itu Pak Joko jawaban saya ke pertanyaan Ibu Sabrina.
Okay. So in this matters of the water quality, yeah. So when we cultivate this fish, we may control the water quality, yeah.
Yes, correct.
In order to get this fresh smell of fish, yeah. Okay. Now I have read here that Bapak Surono Purba, yeah. Please give your question. And I think it is for Dr. Rambucel, ya. Oke, dipersilahkan Pak Surono.
Okay, thank you, Mr. Joko, for the chance. I'm going to asking for my Mr. Bucel.
Yeah.
Okay. My question is, how ingredients to fish powder, and how many proteins in fish powder or in fresh fish? Okay, thank you, and thank you, Mr. Bujal.
Okay, thank you, Pak Surono. I think it's already clear, yeah. So please, please, Dr. Ram Bujal, to give your response. Ya, Pak, to Dr. Ram Bujal, yes, please. Great, yeah.
So the question is not very clear. Is it about how to make a fish powder? Is that correct?
Yes, ingredients, Mr.
Oh, fish ingredients, yeah.
Fish powder ingredients, and in the compare with the fish, fresh fish and fish powder, how many proteins there are in ingredients protein?
Okay, to the formula for making the fish powder, I think. That's the question. Okay, please, Pak Dr. Ram Bujal.
Yeah, I think fish powder, what they do is you just steam the fish and take out the bones and all these things just from the meat only. So meat only, and you put in oven, dry. So it becomes like and you grind it, then it becomes a powder. Then ingredients, it depends on what taste you want to develop, like salty salt, and then if you are preparing for the adults, maybe you want to put some chilies. So it depends on the taste of the consumers. There is nothing other things. It's just a pure meat of the fish. And tilapia fish meat is very suitable because it doesn't have a bone, right? You take out the bone. That's why tilapia is better than many other species, like especially carps have a small bones that makes it difficult. So it can be pangasius also. So there's no other rule. It depends. Some people are using just like a meat only, no other ingredients, no powder or anything, but maybe salt and chilies or no chilies, right?
Okay.
It has pure meat of the fish, so it has a high protein. Now you can see it's very probably 60%, 65% protein from the dry matter base. Weight basis, it can be 30%, 25 to 30% weight basis fresh meat that fish normally has, like protein. And main is the protein and amino acids. Also other zinc or those things you need to analyze with. These companies actually are some of the Thai companies. University students prepare that one, and then they give this sample to analyze in the lab, specialized lab. So depends on the which species you use. So there will be slightly different, okay, iron or zinc or those things, but mainly the protein will be almost the same, okay. If you have 6% protein, 65% protein, that is already good for health. High protein can make power. That okay?
Yeah.
Okay.
I think I hope Pak Surono already clear with Dr. Rambujel's answer. So is there other participant?
Can I add the answer, Pak Joko?
Yeah.
Can I add the answer? Some information related with the production of fish powder.
Yes.
Okay. Yes. Okay. Pak Surono, if you're looking for the functional fish powder, because your fish powder you can dry the protein, directly easy to put in the open, exposed to the high temperature, and then remove the water moisture content till the reach 9 to 8%. But the problem is if you expose the fish protein to the high temperature, you will lose the functional properties. So you powder only powder. You lost all the functional property. And once you lost the functional property, you cannot apply in the food product anymore because it look like just a sand, macam pasir, without any functional properties. So in order to protect the functional properties of the fish protein, you can follow the production of the surimi. You follow the production of surimi and adding with addition of the cryoprotectant. So when you produce the surimi, and then you can dry your surimi to produce the surimi powder. Surimi powder become much better than fish powder because you add with cryoprotectant. Cryoprotectant can act as a cryoprotectant because the mechanism is similar. The way the sugar and phosphate protect the protein during the freezing process is similar during the drying process. So sometimes cryoprotectant with actually is sugar and phosphate are so called as cryoprotectant. Cryoprotectant to protect the protein during the lower temperature, cryoprotectant to protect the protein during the drying or high temperature, and then your fish powder become with functional properties. It's a way to produce a good quality of the fish powder, and we call it the surimi powder. Okay, thank you, Pak Joko.
Yeah, you're welcome, Pak Nurul Huda. I give one more participant for giving the question. Please, one more participant.
Yeah, maybe I can just add to this question, Professor
Yeah.
Huda. Temperature, like you're talking about 100 degree or higher than 100 degrees Celsius that destroy the protein, right?
No, no, you cannot use 100 degrees Celsius. You just only can use until 60 degrees Celsius. If you expose the fish protein to temperature more than 60 degrees Celsius, you will break down the protein and then you lose the functional properties. We're talking about the quaternary structure of the protein, not the primary structure of the protein. The protein is still there, but lost the structure that benefit for the placing in food product. So once you lost the quaternary structure of the protein, and then you're not able to apply in food product anymore, because this kind only a powder only without any functional property. The ability to bind the water loss, the ability to bind the oil loss. Then it's cannot easy to apply in the food product anymore.
So basically, suppose if you deep fry the fish, then do we lose all the protein?
No, you not lose the protein, Dr. Ram. Not the protein still there, but you change the structure of the protein.
Yes,
you lost the structure of the protein.
This is the big issue. Like people buy fish in the hope that they will get good protein, but by the time they cook, they will boil, it goes above 100. And by the time they deep fry or grill, actually temperature goes maybe 100, above 60, let's say. In that case, do you mean that most of the protein, that functional protein will not be there? That means that has a low value for human health, right?
This one is not about the amino acid, but the functional property. Look like if you expose the flesh to the high temperature, the flesh become dry. Then once the flesh become dry, and then the flesh lost ability to absorb, to hold the water. So meaning lost the functional property, lost the ability to hold the water, and then you can apply. Look like if you dry the flesh to the high temperature, and then you use this kind of protein after you expose with high temperature, you cannot use as raw material for the production of fish ball, because they already lost the ability to hold the water because they exposed to the high temperature. It's different story. If you just deep fry the fish and then you consume, you no need to the product no need to come with any functional property, because we directly consume this dried fish, this fried fish. But if we apply the product to the product, and then it's become a problem.
Okay, I think yes, I think each of you already compliment each other. So for Pak Surono, I hope you can catch what the answer was. And yes, basically we cannot hit the fish at very high level of temperature in order to keep the structure of protein staying there. Okay, participants, dear speakers, I think let me close this session. Or is there other questions for this afternoon before I close the session for discussion? All right, so now is the time for closing session for the plenary, and I would like to let the committee for taking the photo of all speakers, and then maybe with full screen of the participants. Yes, Pak Fauzi, Bu Trisla, please do so. And then we will give the certificate to our honorable speakers. Am I correct, Bu Trisla, Bu Windarti? Sudah diambil fotonya bersama teman-teman panitia?
Belum Pak, kepada Bapak Ibu dipersilakan.
terlebih dahulu. Terima kasih. Mengaktifkan kamera terlebih dahulu, Pak.
Okay. Okay. Would you wait for a moment, please, to set the camera for group photo, or especially for the speakers? Before I close this session also, while waiting for the committee to prepare the camera, I would like to announce that tomorrow morning, we will start at 8 o'clock, Western Indonesian time zone, and there will be 6 parallel sessions. So each parallel session will be led by one moderator. So who will be presenting his or her works must be ready at 8 o'clock by tomorrow night.
Satoshi-san, how are you? Halo Satoshi-san. Dr. Nurul Huda. Halo Satoshi.
Hey.
How are you?
I'm fine.
How in Japan? Everything is okay?
Yeah, for now, but still, how to say, COVID issue is a problem.
Okay.
Yeah. How about you?
Fine, thank you. I hope you someday we can take some sample in Sumatra. If the pandemic was gone, Corona was gone, maybe we'll make sign also. MOU, yes. I already asked my dean to make some collaboration with you.
Yes.
Yeah. Gitu. Pak Nurul Huda, Dr. Nurul Huda. Ada salam Pak, ada salam dari teman kompaknya katanya Pak Sapril Siregar.
Oh iya.
Sama-sama di Bogor dulu Pak.
Iya. Sudah lama tidak jumpa.
Setting saya tadi.
Iya, sudah lama tidak jumpa. Salam kembali lagi Pak Sofyan.
Oke.
Halo,
Profesor Rambuzel.
Dr. Rambuzel. Sinyal bisa.
Bagaimana teman-teman komite?
Dr. Ram, where are you now? In Bangkok or what?
Bangkok, yeah.
Bangkok. Okay. Oh, in Kathmandu, huh?
Hello, Dr. Ram.
Hello. I'm in
Dr.
Bangkok.
Ram.
Yes. Lisa.
Hello, Satoshi-san. Did you still meet with Professor Imai Sensei?
Yes. Sometimes we meet at a conference or
okay.
Yeah, and then last year I invited him to Chile because I have a
Chile together for your give lecture in Chile. I saw in
yes.
your
Yeah.
Okay,
so
please, if you meet Imai Sensei, please send my best regard for him.
Okay, yes, of course.
I miss so much the Imai Sensei.
Yes. Thank you.
Is your university running the classes or no?
So in Malaysia, no class until December, only online.
Yes, I think Indonesia the same. Yeah. How about in Japan, Satoshi-san?
Japan, it depends on the prefecture.
Depend on the prefecture.
Yeah. Around Tokyo, still many people are newly infected, so maybe pretty dangerous. But I think schools already open and students are commuting, learning at school. I think.
Yeah. Okay.
All are open.
It's good.
All are open. And so Thailand is #1 in terms of safety this virus problem. Okay, Thailand was ranked number 1. So all the schools and offices are open. Only problem is that tourists are not coming.
Halo, Bapak Ibu panitia. Masih lama kah? Atau bagaimana nih?
Panitia mana panitia? Mas.
So in Malaysia for the primary and secondary school, yes, open, but only for
Pak,
university.
selanjutnya fotonya sudah selesai Pak, boleh di
University just until
closing
December.
lagi
Iya.
Pak sekarang Pak.
Terus penyerahan sertifikat untuk pembicara bagaimana?
Gimana Pak?
Apa lagi Mas? Apa lagi? Lanjutannya apa lagi? Setelah ini apa lagi?
Penyerahan sertifikat kan? Penyerahan sertifikat enggak?
Iya Pak, iya.
Iya.
Nanti akan diserahkan Pak.
Berapa lama lagi?
Halo Dr. Ram.
Yeah, we're teaching online, so our university is not closing.
Sorry?
Our university not closing. We are teaching online.
Oh, I see. So, we hope this condition is normal early, no? So you can visit again in our university, and then maybe sometime I can come to the AIT.
Yeah.
I miss the AIT so much.
November, maybe they will allow to come anybody. I think. It depends which country has more virus. They will not allow from that country.
Okay. So, Dr. Ram, so on behalf of the committee, I say thanks to you for nice presentation today. Yeah, hope maybe for another conference, I can invite you again to come to Indonesia.
Yeah, thank you. Last time when it was 2015, right?
Biar ada chat aja, Mbak Joko.
Yeah.
Last time in 2015, I came to your university.
Yes.
Okay. Dear participants and also the honorable speakers, I think it is the time for saying goodbye for a moment. And now in western part of Indonesia is already approaching 4 o'clock, I think. Yeah, in Japan maybe it's already at 6 o'clock, I think, in the evening ya. Dan di Malaysia, di Sabah, barangkali Pak Nurul Huda juga sudah harus bersembahyang maghrib ya Pak ya. I think time for us to say goodbye. Once again, many thanks. We are so sorry if there are some uneasy or unsmooth process due to this online seminar, and the topics are really meaningful for us to add our knowledge, or for some maybe to refresh, because we have been doing this for years, and always there is something new, always there is something reminding for us, and I think we might keep in touch from now and then for the sake of the development of science. Yeah. Once again, thank you very much, Dr. Rambujel, Pak Nurul Huda, Dr. Sofyan Regar, and also Dr. Satoshi Nagoi. Yeah, all of you are very great. Yeah, many thanks also from the committee who have been working very hard to prepare this webinar. Yeah, I think for me personally, I apologize also for the things that may be not proper for you, and a warm goodbye, stay healthy, and stay motivated. Demikian, terima kasih Bapak Ibu, seminar kita pada hari pertama ini. So tomorrow we will meet at 8 o'clock dengan topik paralel, ya, ada 6 kelas, nanti masing-masing akan dipimpin oleh seorang moderator juga. Demikian, terima kasih teman-teman dari Sabang sampai Merauke ya. Saya pantau tadi ada dari Sumatera Utara sampai dari Papua Barat. Terima kasih perhatiannya. tadi sampai 122 orang tadi saya pantau yang ikut secara langsung ya. Demikian, terima kasih. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh dan selamat sore, selamat pagi, selamat malam.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih,
Oke,
Pak.
Satoshi Sang. Bye-bye semuanya. All of you, thank you.
Thank you all.
We'll meet in short time. Oke. Oke. Tadi sertifikatnya bisa diserahkan ya? Ini sudah.
Sekarang ngasih makanannya pas udah mau selesai.
Hai adik.
Siapa adik?
Bang Gali.
Tika.
Ada. Geli.
Besok jam 9 pula ya kan, Dek? Mau kebangun.
Pada Bapak Ibu sudah bisa dipersilahkan untuk live. Terima kasih.